So we're going to do quadratic functions on their models. And so here, a quadratic function is any function with a degree 2. Cubic functions have degree 3. Quartics have degree 4, but we're just going to do quadratics. And so kind of like our section on linear, this will be dealing with quadratic equations. We're going to do certain things with it. So here's a standard form of a quadratic equation. So given this, we can write it in what we call quote unquote standard form, where it's ax minus h squared plus k. And the reason we write it in here is notice that after we did our whole section on graph transformation, you can easily, well not easily, but it's easier, let's write easy, say it's easier to see how this graph works in this way. Because here we know at the center, or the vertex, right? The vertex here is going to be at h and k, right? Because I'm going to move my point to the right by h, so it already has the negative sign in there. As we remember, moving stuff, moving, if I minus this minus here means I move to the right by h, and this plus here means I move up by k. A is how much we've stretched or shrunk it vertically, and we're going to do everything vertically because we'll just pull it out of the square. And so here, we're going to put these, so we're going to complete the square. And so I said, completing the square is kind of an odd way to solve for problems, and it is, right? In my opinion, it's a little bit odd. But it is a great way to graph these things. And so here we're going to complete these squares and then we can graph these things. And also knowing the vertex is often what you kind of want for word problems and in life. And so the vertex is an important point, and so we can easily tell what the vertex is in this case. So let's do the first one. All right, so here we're going to complete the square. So let me do this simply. I'm going to use y instead of f of x. You can use these interchangeably in this class, more or less. Are they technically the same? Kind of, because here when we write y here as of 2x minus 12x, and then I'm going to leave a space here and then add the 22. So here I've kind of written y as a function of x, and so yeah, it's interchangeable. All right, so how would I do this? So the way I would do this is the following. So completing the square, given a is not 1, is a little bit more interesting. So I write it this way. So I just write the, oops, I forgot my square term. So I write my square term, my x term, so x squared term, my x term, and then I leave a blank, right? I leave a little blank spot, write this all in parentheses, and then kick out my constant term. Then the next step I will do is I will pull out whatever the a is here. Whatever this a is here, I'm going to pull that out. And so in this case, it's 2. So I pull out a 2. And so I have x squared minus, now I pulled out a 2 here, need to pull out a 2 here, 6x, still leave this blank spot. I'm going to add 22. Okay. All right, now I need to complete the square. So to complete the square is I take b squared over 2, or b over 2 squared. And in this case, our b is negative, or our b is negative 6. So negative 6 over 2. So write that negative 6 over 2 is squared. So this is 3 squared, so that's 9. And so I'm going to put that right in here. I'm going to add 9 here, okay? Now if I add 9 here, I want to add a 0. So I'm going to add 9 and take away 9. But if I added 9 inside the parentheses, notice I really added 18, right? Because it's 2 times this 9. So here, I'm going to minus out 2 times 9. And this 2 comes from here, and the 9 comes from here. Okay? Basically what I'm doing now is I'm adding 18, dividing it by 2, and putting it here. And then I'm minusing 18 and putting it here. And so by adding and minusing 18, I haven't changed any values because I'm adding a 0, really. So now once I've done that, I can simplify all this. And so this just becomes y equals 2x minus 3 squared. So complete the square. So this becomes x minus 3 or x minus b over 2. Okay. Then 22 minus 18 is 4. All right, so if I was going to graph that, I'd go over 3, 1, 2, 3. I'd go up 4, 1, 2, 3, 4. Put my vertex right here. And then since a is 2, I'm going to go over 1 and up 2. And then I'm going to go over 1 and up 2. And so here, this distance right here I travel is a, which is equal to 2. Okay? And then I can draw in my parabola. Okay. Now, when you do this on the homework, you're going to have a little tool. It's going to have you place down a vertex, and then it's going to place down, then you're going to place one other point, and then the tool will draw in the rest for you when you do the homework and when you do everything on the exams and stuff. So that's going to draw it in for you. Therefore, so how do you figure out where the next point is? Well, the next point would be over 1, up 1 if it was just a normal parabola, right? Well, here we're just going to go over 1 and not 2, whatever my a value is. And I'll show you here again. All right, so let's do this again. So here we're going to have y equals minus 3x squared minus 12. I'm going to leave a blank. Minus 10. So I moved everything over. Here, I'm going to pull out my negative 3. So I have negative 3x squared. This becomes positive 4. So if I pull out negative 3, this becomes positive 4. Leave a little blank. Minus 10. So to complete the square here, so b over 2, oh, sorry, I forgot my x, sorry. So b over 2 in this case would be 4 divided by 2, which is 2. 2 squared is 4, so we're going to add a 4 here. But notice, if I add a 4 here, I need a minus a 4 here times my negative 3, right? Oops, I guess I didn't leave myself enough room. Oops. Not even on the right layer anymore. I know how to fix this. Oops, nope. Fresh. I'll just draw it in white real quick. It's a terrible thing to do. And here we go on the right layer. Let's switch back. Minus 10. And so we need to minus a 4 times negative 3. So if I add something here, and you're always going to add here because anything squared, you're going to minus it out here, multiplied by whatever your a is. So here, this is negative 3. When I complete the square, this is x plus 2 squared. If you have trouble completing the square, go back to the one section where we did it. So this would be minus 10 minus 4 times the negative 3. So this would be minus a 12. So this becomes plus 12. Let me not skip that step. So this would be minus a minus 12. And so so this is x plus 2 squared is plus 2. Oops. Not an equal plus 2. There we go. All right, so where's my new vertex? My new vertex in this case is negative 2, 2. So I'm going to move over 2, 1, 2, and go up 2, 1, 2. So that's my new vertex right here. So that's my vertex. So over 2, up 2, just like we did when we transformed the graph. Now, in order to draw my next one, I'm going to go over 1 and down 1, 2, 3. So I'm going to go down A, and over 1 and down A. And so this A right here is how much I'm going to travel here. And so this distance here is A, which is equal to minus 3. And here I've drawn in my parabola. Okay? All right, let you copy that down. So what are we doing here? Let you guys copy it. We're going to take whatever this is. Let me just zoom out just one tick real quick. We're going to take whatever this is. So it's going to come to us in this form. I'm going to put it into this form so we can graph it. Where it's H and K is my vertex, and A is how much I squash or stretched it. And it also tells me if I open up or open down. Okay. All right, let's go to the next one. Let's zoom on in. All right, so do we need to do this? So technically, you could follow this process with just leaving the variables. And so this is somewhat of a proof. And so here, we're going to go ahead and say y is equal to ax squared plus bx, leave a space, plus c. And so we're going to just follow this process as if without knowing what the actual letters are. And there's a reason for it. Now, let me do that. X squared, this would be, so if I pull out an a, this would be b over a x space plus c. We're going to complete the square, so we'll have ax squared plus b over a divided by 2 squared is just going to be, if I don't know what that is, it's just, we're literally just going to write that is b squared over 4a squared. And that's just, if b over a is my technical b and I divided that by 2 and then squared, that's going to give me b squared over 4a, if you did all the math out. Okay. I'm going to add c here. And so here, we add c, so we added it here, so we need a minus it here. So b over 4a squared times a. And let's just simplify this real quick. Becomes a over x plus b over 2a squared plus c minus b squared over 4a. All right. Now, why do I give this to you? Well, here, no matter what numbers I give you, engineers like little formulas. And so here's a formula for you. You can just, you don't have to figure out how to complete the square. Just, if this is a, b, and c, well, if I want to put it in standard form, I just calculate these numbers, right? You just calculate the numbers and just go through it. A is here, x is here. Take b divided by 2 times a, that goes here, squared. And if that's negative, we put a negative sign here. If it's positive, we'll take c, and then we'll minus b over 4a, and that's how much goes up. And so technically, I know what the vertex is. The vertex of any point is negative b over 2a, because remember it's minus h here, and then c minus b squared over 4a. And so here, the vertex of any quadratic function is given by the following, if you know a, b, and c. Now, why do we care about this? Well, we need to care about min and maximum values. So the minimum or maximum value of a quadratic function occurs at the vertex, which makes a whole lot of sense, right? And that vertex occurs where? Where x equals this, right? Where x is equal to that, because that's where it occurs. So another way, instead of calculating this mess, right? Instead of calculating this, you can just plug it in. Now, if you plug it in, it's going to give you the exact same answer as it's going to give you the exact same answer as this. It just works out that way, right? Um, and so here, so you don't have, you can either calculate this or you can just plug this in the function value. I find this actually to be a little bit easier, so that's what we're going to be using. So the minimum maximum value occurs at the vertex where x is equal to this, and the value of that function is either negative b over 2a, or so it's either min or max, depending if your a is greater than 0. If a is greater than 0, it's a minimum value. If a is less than 0, it's a maximum value. Um, so there's two ways of doing this. So find the min or maximum values of the function and graph them. So the first thing you can do is either complete the square like we did before, or in this case, we're just going to compute the numbers. And so here, let's just compute the numbers. So here, I was going to compute this, x equals to minus 2b over 2a. Well, in our case, what's b? B here is 4, so it's b minus 4 over a here is 1, so 2 times 1. So my x value here is minus 2. To find out what my function value is, so f of minus 2, well, here we're just plugging in. Negative 2 squared is 4, plus 4 times negative 2 is minus 8, so 4 minus 8 is indeed negative 4. And so here, my vertex occurs at negative 2, 4. Yep, minus 4. So I can go ahead and plug that in. So I go over 2 and down 4. 1, 2, 3, 4. And here my a is 1, so I just go over 1 and up 1. And just for my own sake of drawing it, I'll draw in the next points. And there you go. Okay. And so what is this? Find the minimum maximum value. This one has a minimum. And where's the minimum? The minimum is here at negative 2, 4, or minus 4. That's the smallest this thing can achieve. And it has no maximum, because if I went this way or that way, either way, I can go up forever. Let's do this one. Here, we'll give this again. So let's go ahead and here. So a is equal to minus b over 2a. So b in this case is 1. So this will be negative 1 over 2a, which is negative 1. So that means x equals a half. To figure out what my y value is, I just plug in the function value for half. Oh, this isn't going to be as clean as I like, so let's just crunch through it. So we have 1, so minus 1 half squared plus 1 half plus 2 is equal to minus a fourth plus a half plus, let's make my life easier. This half, let's make this half 2 fourths, and this 2 8 fourths, so it gives me 9 fourths. Okay, so here we have our at 1 half 9 fourths is our vertex. All right, so let's just plug that in. So at a half and 9 fourths would just be a little bit, so be about here, a little over 2. And it's going to go over and down negative 1, and then over and down negative 1, and opens up. Okay, and so here we have a maximum, and this is a max. This is our max, our local maximum. In fact, not only is it our local max and mins, they're actually global max and mins. So this is either label would work. Okay. All right, so let's solve one little problem, and we'll call it good for the day. And I'll give you some extra time to do your homework. Boop. All right, so when we use this, so gas mileage car is based on the speed of a given vehicle, assuming many things are constant. Um, and just to get some feedback from you guys today, what are some of the factors as engineers? What are some of the factors that may affect gas mileage besides the speed of the car?
The weight of the car,
Oh, let me turn you up. I couldn't hardly hear you. Say it again.
the weight of the car, and
Yeah, the weight
things
of the
besides
car,
it.
the quality of the car. Yeah, so which car you have matters, right? Um,
Air friction
yeah,
from
air
the
friction.
wind.
So it's actually humidity makes the air more dense, right? Um,
Oh,
if you're and so other things, if you're the elevation. So if I'm driving a car on a horizontal line, that's massively different than going up, right? A hill.
mm,
The type, the quality of the road matters. And so if I'm going on a bumpy road, it just takes more juice. Um, and so there's a lot of things with the car, even if the same car, right? The weight of the car can change, right? Because if I just bring, if I drive myself to work, big deal, right? If I pack, six of my friends in the car and drive, it's massively different, right? And I get less gas mileage. And, um, but let's just say speed of a car, and this is actually not actually a terrible. This right here isn't a terrible um, estimate of it, right? If the speed of the car is between 14 and 70 miles, up until 14, you usually a lot of your juice is just used to get the car going, and so it just use more juice. And then after to keep the car going, and after 70, it just takes you're just fighting so much of your other factors of resistance, air resistance, all that. It just doesn't follow the model. But between miles of 14 miles per hour and 70 miles per hour, this usually is um, quite actually a good estimate. So let's actually run through this. So, what is the best? So, if this is the formula for that, what's the best miles for this car? Well, here we just want to find S, right? Since this opens downward, we just want to find out where um, this car gets the most miles per gallon, right? And so we want to know what's the best miles per gallon this car can achieve. So that's how efficient your car can be and what speed it occurs. So we'll start at the speed. So S, or aka X, right, is equal to minus B over 2A for this quadratic equation. And so here this would be minus 3 over 2 times negative 28th. Um, and so let me do something real quick. So that'd be, so the negatives cancel, right? This would be, I divide by the 2, I get 14. 3 times 14 gives me 42. Okay. So this curves at 42 miles per hour. Okay. So that gives us that. And then in order to find out M, we just plug in M of 42. And here I just run it through this. So minus 28 times 42 squared plus 342 minus 31. Chunk that through a calculator, you'll get 32. And so 32 miles per gallon is the best this car can achieve. Car can achieve. And, and that occurs at 42 miles per hour. Okay. So it's always just for future reference when you're answering a word problem, it's always nice to write the answer out as a sentence. Um, I mean, I won't dock you down for it, but it's just something good to see. If you're given a question, to answer very specific things, answer it as with the specific things. In this case, it's like, what's the best miles per gallon? Well, 32 is the best mile per gallon this car can achieve. I forgot the word of this. This car can achieve. And that occurs where? At 42 miles per hour. So we can use quadratic models to solve things. And that is the end of it.